Hey everyone, welcome to this Unreal Engine Blueprint tutorial. In this session, we're going to build a simple but classic example, a coin collecting game. Through this project, we'll go step by step and learn some of the most important blueprint techniques in Unreal Engine. As you'll see in the demo, when the player gets close to a coin, the coin will automatically move toward and attach to the player. This kind of effect is really common in both action and casual games, and is mainly achieved through a clever use of Unreal's Blueprint event system. The project itself is simple and straightforward, perfect for anyone who's just starting to learn blueprints. By the end of this lesson, you'll have a good understanding of how to think in terms of blueprints in Unreal Engine, how to design event triggers and responses, when and how to call particle effects, and how to randomly distribute scene elements. To help you get comfortable with all of that, we'll go through 5 main steps: project setup and asset preparation, building the basic blueprint framework, developing the core functionality, adding and integrating visual effects, and finally, random placement and testing of scene elements. We'll go over each step carefully, one by one. The whole session should take around 30 minutes. Alright, let's jump right in. First, let's go over how to create a new Unreal Engine project and organize the assets that we'll be using in this tutorial. Next, I'll show you the step-by-step process. Open Unreal Engine. In this tutorial, we'll be using Unreal Engine version 5.6. In the Unreal Project browser, switch to the Games category. Here, choose the third-person template. Then set the project type to Blueprint. Next, choose where you want to save your project and give it a project name. Click Create to start building the project. Once the project is created, Unreal will automatically open the third-person level for you. If for some reason it doesn't open automatically, you can find it manually in the content browser under the third-person folder. Double-click the level file to open it. Now let's test the level to make sure everything runs properly. Click the play button. You'll see that Unreal automatically spawns a third-person character which you can control right away. Great, everything's working fine. Press ESC to exit play mode. Next, we'll add some assets to our level. All of the assets used in this tutorial come from the Fab Marketplace. In the content browser, click the Fab button to open the marketplace. In the search bar, type coin. Fab will display all the coin-related assets. You'll notice that some of them are paid, but there are also plenty of free options. For this tutorial, we'll use this free coin asset. Click on it to open the details page. Click Add to Project to import the coin asset into your current project. Once added, you'll find a new Fab folder in your content browser. Open it, then go to the coin subfolder. Here, you'll see the coin model and its materials. Open the coin's mesh. We'll make a few small adjustments to its material. Adjust the metallic and roughness parameters. Increase the metallic value to give it a more reflective, metallic look. Lower the roughness value slightly. Next, let's change the coin's color. Adjust it to a golden tone so it looks like a gold coin. Once you're done, click Save All to save your changes. Now let's add some sound effects for our game. Just like before, open the Fab Marketplace and search for Sound Pack. Fab has a wide range of sound packs, some paid, some free. We'll be using this free sound pack for this tutorial. This pack contains a lot of high-quality sounds. Click Add to Project to import it. You might see a pop-up warning that this asset was made for Unreal 5.4. Don't worry, it still works fine in 5.6. Just select version 5.4, and click Add to Project again to import it. Once it's added, go back to the content browser. You'll find the imported sound pack folder. Inside, there's a Y folder. Open it. Now let's find a suitable sound for the coin pickup. Search for coin and you'll see about 15 coin-related sounds. Feel free to listen and pick the one you like. Alright, that completes our asset preparation. Next, we need to create a coin blueprint class. Most of the logic in this project will be built inside this blueprint. So based on the game rules, we'll set up the basic logic framework in the coin blueprint. When the player enters the coin's detection range, it will trigger a sound effect. Open the content browser, right-click anywhere inside the content browser, create a new folder and name it BP. We'll keep all our custom blueprints organized inside the BP folder. Right-click here again. We need to create a new coin blueprint class. Select Blueprint Class. Then choose Actor as the parent class. Name this blueprint BP coin. Open it. Now, we'll import our coin model into this blueprint. Find the coin mesh in the content browser and drag it into the components list of the blueprint. You should now see the coin model appear in the blueprint viewport. Next, we'll give the coin a bit of dynamic motion. Click the Add button in the components list. Search for rotating movement. Add this component to the blueprint. With this component added, the coin will automatically rotate. You can check its rotation settings in the Details panel. By default, it rotates around the Z-axis at 180 degrees. That looks pretty good for our case. Click Compile, then go back to the level window. Drag the coin blueprint into the current level to test it. Click Play to test. Now we can see the coin freely spinning on the Z-axis. Okay, stop the play session and return to the coin blueprint. Next, we'll set up how the coin detects the player. First, we'll add a sensor to the coin. With this sensor, the coin can detect when the player gets close. We'll use a sphere collision component for this. Select the coin mesh in the components list. Click Add. Add a sphere collision component. Okay, now this component defines the detection range of the coin. The coin looks a bit small, so let's scale it up a bit. To make it easier to adjust, click the little lock icon next to the scale setting. This locks the X, Y, and Z axis together. Then, set the scale value to 1.5. Next, select the sphere collision component. We'll set its radius in the Details panel. Adjust the radius to around 150 units. That'll be the detection range of the coin. Now the coin can check if a player enters this 150 unit range. If so, it will send a signal back to the blueprint. Switch to the event graph. First, we need to get the player character. We'll store the player reference when the game starts. Let's get the player controller first. Then we'll bring in the character controlled by this player controller. If you check, the player controller is controlling the third-person character provided by the default template. In the third-person folder, open the Blueprints subfolder. This is the blueprint for the player-controlled character. Press Ctrl+C to copy its name. Then, go back to the coin blueprint. Paste the name into the search bar. You'll see CastleBP third-person character in the list. Click it. Connect it to the Event Begin Play node. The output from this node is your player character. Store it as a variable inside the coin blueprint. This will make it easier to reference the player later. Okay? Next, we'll use the sphere collision to detect the player. Select the sphere collision component in its Details panel under the Event section. You'll find on Component, Begin Overlap. Click the plus button next to it. This adds a Begin Overlap event. This overlap event outputs every actor that starts overlapping with the coin, so we need to filter them. We'll check if the other actor is our player character. Get the stored player variable and compare it to the actor from the overlap event, and see if it matches the player blueprint. Use a branch node to perform the check. If it is indeed the player character, then proceed to the next step. The next step is to play a sound when the player approaches the coin. We'll attach the sound to the coin component. Right-click in the event graph. Add a spawn sound attached node. Here, we can assign a coin sound effect. Search for coin. Pick the one that fits your project. And that completes our simple interactive setup. Click Compile. Go back to the level viewport. Run the level. Let's test it. When the player gets close to the coin plays a sound. Next, we'll work on the core feature of our coin blueprint, the interaction animation between the coin and the player. This will include two parts. First, the animation where the coin flies toward the player when they get close. Second, the animation where the coin disappears after reaching the player. Go back to the coin blueprint. First, we need to get the starting position, which is the coin's current location. The target position will be the player's location. So we'll get the player controller. Then using the player controller, we'll get the player's position. Now that we have both the coin's position and the player's position, we can use a LERP node to smoothly move the coin from its position to the player's position. The alpha input on the LERP node controls how far the coin moves between point A and point B. We'll control this alpha value over time using a timeline node. Right-click and create a timeline node. Open the timeline editor. Add a float track to the timeline. Name this float track alpha. Set the length of the timeline to 1 second. This means the coin will take 1 second to reach the player. You can adjust this depending on your project's needs. Now, let's add keyframes to the track. At time 0 seconds, set the value to 0. At 1 second, set the value to 1. Okay, take a look at the timeline. As time goes on, the value smoothly increases from 0 to 1. Go back to the event graph. Use the timeline's output float value and plug it into the alpha input of the LERP node. Each time we play the timeline, it should start from the beginning. So connect it to the play from start input of the timeline. Next, we'll control the coin's animation by setting its position. Create a setActor location node. Connect the LERP output to the new location input. Once everything's connected, click Compile. Then go back to the level viewport. Let's run the level and test it out. Looks like the player just got knocked back by the flying coin. This happens because of the coin's collision settings. Select the coin's static mesh component. In the Details panel, find the collision settings. Set it to No Collision. After applying the change, let's test again. Run the level. Okay, now the coin flies smoothly toward the player's character, and that's exactly what we want. Exit the play mode. Go back to the coin blueprint. Next, we'll make the coin disappear after it reaches the player. So first, we'll define the condition for when the coin should disappear. We'll measure the distance between the coin and the player. When the coin gets close enough to the player, we'll destroy the coin blueprint. Use a distance node to calculate this. Connect the player's location to it if the distance between the coin and player is less than 50 units. We'll destroy the coin blueprint. Use a branch node to check whether the distance is less than 50. When the coin detects that the distance to the player is less than 50, it will execute a destroy actor command. Click Compile and go back to the level. Run the game again to test. Okay, everything looks good. We've now completed the basic logic for the coin blueprint. we can add some particle effects to the process of collecting coins. This will make the action feel more dynamic and less repetitive. First, we'll create a Niagara system to build the particle effect. Then we'll call that Niagara effect from the coin blueprint at the right timing. Open the content browser, add a new folder, and name it FX. We'll keep all particle effects inside this folder. Open it. Right-click inside the folder and create a Niagara system. Click Create Empty Niagara System and give it a name. Open the Niagara System Editor. First, we need to add an emitter to the system. Right-click and choose Add Emitter. Since the effect we're making is quite simple, we'll skip using any templates and directly choose Add Minimal Niagara Emitter. Next, let's adjust the emitter's basic settings. Change loop behavior to self. Since we only need this particle to fire once, set loop mode to once. Now, let's set up how the particle will spawn. We'll make it burst instantly when triggered. Add a spawn burst instantaneous module. Change the spawn count parameter to 10. Next, we'll adjust the color and shape of the particles. In the Initialize Particle section, set the particle's lifetime to 0.35. Then, let's define the particle's color. We'll make it a color close to the coin, like gold. To make it glow, increase the brightness V value to 20. Click OK. Now the particles emit light. Next, we'll set the shape of the particles. You can control the shape by adjusting its size. Set the sprite size mode to random non-uniform. This allows random variation between minimum and maximum values. Set the minimum value to 0.5. Set the maximum x value to 1. Now the particle shapes look slightly stretched. Our particles now have lifetime and shape, but no velocity, so they just flicker in place. Let's give them some speed. Under the particle spawn section, add a velocity module. If you see any warnings, just click Fix Issue to resolve them automatically. Now the particles move dynamically. Change the velocity mode to from point. This gives the particles a nice explosive burst. The speed looks a bit too slow right now. Let's increase velocity speed to 500. Now the particle burst feels more energetic. Next, in Particle Update, add a Scale Sprite Size by Speed module. This allows the particle size to adjust dynamically based on speed. Make sure the min and max size values match the ones we used earlier. Minimum is 0.5 and the maximum is x1, y10. Set a velocity threshold to 2000. Right now, our particles move vertically. We'll fix their direction. Find Sprite Renderer. And change alignment to velocity alignment. Also, set facing mode to face camera. Now, the particles align with their motion direction. If the particles look too large, we can reduce their size a bit. Set both maximum values to 6. Looks much better now. Let's save the system. Open the coin blueprint. We'll now add the Niagara particle we just created. First, create a spawn system at location node. In the content browser, select the Niagara effect and assign it to this node. the particle should spawn at the player's location. Let's organize the blueprint nodes for clarity. We'll trigger the particle right before the coin is destroyed. Click Compile, then go back to the level and run the game. When the player approaches the coin and collects it, the particle effect will play. Compared to the previous version, this one feels smoother and more natural. Now, let's talk about how to set up coin placement in the scene. In theory, Unreal Engine provides us with an infinite world space. So before placing coins, we first need to define the area where the coins will appear. Then, we'll use the level blueprint to control how the coins are spawned within that area. Let me walk you through the process step by step. First, we'll determine the placement area for the coins. We can use a built-in tool to define this area. Open the Place Actors panel, go to the Volumes tab, select Nav Mesh Bounds Volume, drag and drop it into the scene. Then open the Details panel. In the Details panel, reset its position to 0. Scroll down to find the brush setting section and adjust its size. Set Z to 1000, X to 3800, and Y to 3800. These dimensions are what I tested earlier for this example. Now, move the volume upward a bit along the Z-axis. Press the P key on your keyboard to build the navigation data. Once the nav data is built, you'll see green areas across the scene. That's the area where our coins will be placed. The placement logic will be handled in the level blueprint. Open the level blueprint. Right-click and create a spawn actor from class node. This node will help us spawn coin blueprints into the scene. Now, add the coin blueprint we created earlier. Find the coin blueprint and assign it to the node. Next, we'll set the coin spawn position. Right-click the spawn transform pane and choose split struct pane. This will let us edit only the transform's position. We don't need to adjust the coin's rotation or scale, only its position. Next, let's create a custom event. We'll use this event to handle coin spawning and refreshing. When the level starts, we'll call this event to spawn coins. So we'll trigger the custom event we just created right after the event begin play starts. We'll also add a timer, so coins refresh periodically. Use a set timer by event node to set up the timer. Set the time value to 0.1 seconds. Enable looping so it keeps running. Connect the set timer by event node to your custom event. Now, let's check how many coins exist in the scene. Use the Get All Actors of class node and select your coin blueprint. This will output all coins as an array. To know how many coins there are, just use the length node. We'll check if the number of coins is less than 100. Use a branch node to test this condition. If it's true, add a small delay of 0.1 seconds. Then spawn new coins and connect it to the spawn logic. That's the main logic for spawning coins in the scene. Now, let's randomize where the coins appear. We'll make them spawn randomly around the player. So, first we need the player's current position. Right-click, create a getPlayerCharacter node, and use getActorLocation to get their position. Next, use getRandomReachAblePoint in radius. This works together with the NavMeshBoundsVolume to find a random reachable location near the player. Set the radius parameter to 10,000. We don't want coins to appear directly on the ground, so let's give them a little height offset. Add 80 to the Z-axis position. connect the final position result to the spawn transform location input. Once everything's connected, click Compile, go back to the level viewport and run the game. Now the coins will spawn randomly within the area we defined, and when the player gets close, the coins will fly toward the player for collection. Finally, let's take a moment to review what we learned in this lesson. The core logic of this project is all built inside the coin blueprint. In the coin blueprint, we use the event begin play node so that when the game starts, we can use get player character and cast to BP third person character to get the player controlled character and store it as a variable in the coin blueprint. We added a sphere collision component to detect the area around the coin. Using the onComponent begin overlap node, we check whether the player has entered the coin's detection range. When the coin detects the player, we use spawn sound attached to play a sound effect. We then used lerp and timeline nodes to interpolate between the coin's position and the player's position, and control the animation of the coin flying toward the player using setActor location. The distance node was used to measure how close the coin is to the player. When the distance is less than 50 units, we trigger spawn system at location to play a particle effect, and then destroy the coin using destroy actor. Now, about the random placement of coins in the scene, we first used a nav mesh bounce volume to define the area where coins can appear. Then, in the level blueprint, we created the logic for spawning coins randomly within that area. We used the spawn actor from class node to create the coins in the scene. For this node, we only needed to calculate the random position and feed it into spawn transform location. The random position was calculated using getRandom reachable point in radius, which first gets the player's position and then picks a random point within a radius of 10,000 units. We added 80 units to the z-axis to keep coins from spawning on the ground. This final position becomes the spawn transform location. Next, we created a custom event to trigger coin spawning. Coins can't spawn infinitely, so we used getAllActors of class to collect all coins in the scene into an array. Then we used the length to get the total number of coins. If the number is less than 100, we used a delay of 0.1 seconds before spawning another coin to make sure coins appear as soon as the game starts. We used event begin play to call our custom event directly. We also added a set timer by event node to control how often coins spawn. And we enabled looping so the timer repeats continuously. Once we finished setting up random coin placement in the level blueprint, we completed the entire tutorial project. If you have any questions while following along, I'd be happy to discuss and share solutions with you in the comment section. That's all for this lesson. Thank you for watching, and I'll see you in the next video.